All right, cool. So we're going to go over the queue data structure today and what the purpose of what exactly a data structure is and the purposes of using them. So the official definition of a data structure is a data organization, management, or storage format that enables efficient access and modification. More precisely, a data structure is a collection of data values, the relationships among them, and the functions or operations that can be applied to the data. Okay. So basically, it's the data itself, how the data relates to itself, to each other, and then the functions that you can do to that data, how you can modify it, how you access it, how you modify it. That makes sense?
Yeah.
Okay. So the queue is a data structure that has first in, first out access. So how you access the data in a queue is the first bit of data that goes in is the first bit of data that comes out. Like we talked about on the phone last night, is a queue is like a line. Like if you go to McDonald's and you're in the drive-through, your car pulls up, and then a car pulls up behind you, then a car pulls up behind that car. That is a queue. And then you get your order, you drop out of the line, and the next person comes up, they get their order, drop out of the line, the next person comes up, they get their order, drop out the line. Now you have an empty line.
Got you.
So a queue has two main operations that you can do on it. Okay. And that is NQ and DQ. NQ is you're taking that data and you're adding it to the queue. And then DQ takes the first element from the queue and takes it out and returns it. So in Python is for a lot of reasons not really my favorite language to do data structures in because how it works with memory, but that's a whole other, it's a whole other story. So Python has these data structures already built in, but we're going to write our own version of it so you can understand how how they work. So these operations NQ and DQ, they have a certain what's called time complexity. Okay. And every algorithm has a time complexity, and that's basically how efficient the algorithm is. But the official definition of time complexity is the complexity of an algorithm is a function describing the efficiency of the algorithm in terms of the amount of data the algorithm must process. Time complexity is a function describing the amount of time an algorithm takes in terms of the input of the algorithm. So, how much time does it take depending on, how much data you have? Okay.
Mm-hmm.
So let's talk about NQ and DQ. So queues are a lot of time implemented on a lower level using arrays. And the reason why is because arrays have a property of constant insertion and constant reading. Because, we always know that,
You said raise or arrays?
Arrays, but the square bracket.
Yeah, correct.
Yeah.
Okay.
So you know how we access arrays in a square bracket, and we can do like array square bracket 0, and that's always going to be the front of the array. It's the beginning. Yeah. It's the 0, right? So they're what's called indexed. Okay. So no matter how big the array is, it could have 1 billion elements in it. Okay. It is still going to take the same amount of time to read array 0 as it would if it only had 3 elements in it, because it's indexed. Does that make sense? We already know where it is. Because as far as how it's implemented, arrays are pointing to the address in memory. So like that data is on your RAM somewhere at some address on your RAM, right? So when you do array 0, it knows to go to that specific address in your memory. And that address will never change. Therefore, it's always going to take the same amount of time to get that address because you already know what it is. If it takes 1 second, it's always going to take 1 second. Does that make sense?
Got you. Yeah.
So we call that big O of 1 or constant time, because no matter how big n is, where n is a variable or x or whatever you want to call it, no matter how big the array is, it's always going to take the same amount of time. So we call it big O of 1. Okay. Because how good is your algebra?
Pretty cool.
Okay. So n to the 0 power equals 1, right?
Correct.
Right. So that's why we say O of 1. Because no matter how, so it's constant time. Okay. So that's all you need to know. Big O of 1.
Okay.
So it's the same thing for adding to an array. It takes the same amount of time to add an element to an array. Okay.
Got you.
So that's also big O of 1. All right. You follow me?
Yeah. I'm taking note.
So now that we've talked about arrays, let's go back to NQ and DQ. So like I said, queues are typically implemented using arrays. Okay.
Mm-hmm.
So in queue, you're adding something to the back of the array. We know that is constant time, right? Adding to an array is constant time. Therefore, the enqueue method is also constant time, because it's always going to take the same amount of time to add to an array. Now, this is a general use case because there are conditions in certain types of queues where this is not the case, because an array can run out of room, in which case you have to make the array bigger, in which case the time complexity changes. But that's what's called a worst case scenario. All right. So on the average case, most of the time is going to be O of 1. But in the worst case scenario, it's big O of n, where n is the size of the array, because you have to make the array bigger if you run out of room. So if you ever hear people say
big O of n.
Yeah. Do me a favor. On your screen right now, I want you to go to Google. And I want you to type in big O notation. Big, the letter O notation. So now click on that Wikipedia link. Now, I want you to scroll down. Now you see that big O. It says f of x equals big O g of x.
Oh boy, that's some. Oh my God, I'm back to school.
Yes. yeah. I'm doing crash course computer science, like university level stuff. Yep. So when I say
I was always good though. Once I understand the formula, I was always good with it though.
That's good. That's good. So when I say big O of n, I'm saying like big O parentheses lowercase n parentheses.
Got you. Okay.
Right.
Okay. I was writing big O of
Parentheses in parentheses. So if I say big O log n, that's big O parentheses log in parentheses. Big O.
so right here, the first one on top, so this one right here, is this like the basic of the formula?
Yeah. So okay. That is the mathematical definition. So time complexity was not born from computer science. Okay. Like math, all these are functions. So remember, we're working with functions here. Functions
Right.
come from math. We've
Right.
always been able to analyze functions because we've always done function analysis on math, because there's many ways to do different functions. Like there's at least 7 different ways to do addition.
Yeah.
So, but each one isn't as efficient as the other one. So what you're looking at is like the pure mathematical version, like f of x function of x equals big O of g of x, where as x approaches infinity. We're not we're looking at it not as in depth as we would if we were doing like theoretical mathematics. Although it can get that deep if you're doing, depending on what you're doing.
Got you.
So, I'm sorry, what were you asking? Can you repeat your question?
So like, what's like the basic like formula for big O? Like, is it this one right here? Like this part? O right
Yeah,
here?
yeah.
Parentheses.
Yeah. So scroll down. I'm pretty sure in this Wikipedia page there is an example of computer science. Okay, analysis of algorithms. Click on that link. Right up, right. Your mouse is right next to it. Scroll down where it says in computer science, it is useful for analysis of algorithms. All right. So this is called technical analysis. Okay. So T of n equals O(n) squared, where T is the number of steps it takes in your algorithm to complete your algorithm. Okay. So let's go down. Man, I haven't taught this in a while. Let's go down to. Okay, stop right there. You see where it says no, go back. Right there, where it says it says f of n equals 9 log n plus 5 log n to the fourth plus 3n squared plus 2n to the third equals big O n cubed as n approaches infinity. So here we have log n squared, and n to the third, right? Each one of those functions, if you were to plot those on a graph as x goes to infinity, they grow at different rates, right? So log n grows slower than n squared. N squared grows slower than n cubed. So like picture the cubic function. It goes up then down then up.
Yeah, that's what I was just imagining.
Right.
A roller coaster.
Right, exactly. Roller coaster function. If x is 10,000, that's much higher than 10,000 squared. Right? Yeah. And that's much higher than log 10,000. Right?
You lost me on that part. Go ahead again.
N square 1,000 squared is bigger than log of 1,000. The log of 1,000 is like, let's see, log 1,000. Log 1,000 is 3. Which is smaller than 1,000 squared. 1,000 squared is 1 million, right? 1,000 cubed is 1 billion. So n cubed is bigger than n squared, which is bigger than log n. Do you get what I'm saying?
Yeah, this problem is just so big.
But it shrinks down to n cubed, and I'm going to show you why. I'm trying to explain to you why that big problem equals O n cubed.
Okay.
And the reason is because as n goes to infinity, the bigger and bigger n is, n cubed overrides everything else. It doesn't matter because n cubed is so big. You get what I'm saying? The bigger n is, the bigger n cubed is. And n cubed will always be bigger than n squared.
Got you.
N squared will always be bigger as n gets bigger than log n.
Got you. So my one thing, so is n getting is gonna always be bigger because that's the variable.
Right. So we're assuming
It's placed in everything.
so we're the same. Okay. When we're doing time complexity analysis, we are analyzing how fast an algorithm will run as the input gets bigger in terms of the input.
Gotcha.
So if we have an algorithm that is going to take a large amount of input, like let's say we're doing image analysis on images from NASA, you know, these files are gigabytes and petabytes big, right?
Mm-hmm.
So you want to have an algorithm that's as efficient as possible to run over these gigabytes and gigabytes of data, because otherwise your computer is going to freeze up and run at a crawl because it's so much data.
Got you.
So in this example right here, we have n logged n plus 5 log n to the fourth plus 3n squared plus 2n cubed equals O to the n, O n cubed as n approaches infinity, right?
Mm-hmm.
Because we can drop the coefficient. You always drop the coefficient. So the 9, the 5, the 3, and the 2, when you're doing technical analysis, that gets dropped. Because in terms of computers, computers get twice as powerful every 18 months. That's called Moore's Law. I'm sure you've heard of that before. So computers are always going to get faster over time. So those coefficients are going to mean nothing over time, right? The same algorithm is always going to run faster on newer hardware. That just makes sense, right?
Question. Hold on. Question. Is that why they coming out with so many phones every year now?
Well, that's part of it. Most of that has to do with marketing.
Yeah. Yeah. Also.
But so you're always going to drop the coefficients, and then you find the term like that is going to grow. That is the biggest term, and which in this case is n cubed. N cubed is the biggest term in this function. So that is going to be the worst case, average case scenario. So we don't care about log n. We don't care about n squared. You always just care about what is the biggest, because that's going to be that's going to be your worst case scenario. Okay.
Gotcha.
Because some algorithms run faster when there's less data than when there's more data, right? So your algorithm, if you only have a little bit of data, it might not be as efficient as another algorithm, but it might be a lot more efficient if you get a lot of data. Does that make sense? One algorithm might be faster for smaller data than another algorithm can be for bigger data.
Gotcha.
All right. So that being
One
said,
second. Hold on. Go ahead.
with that being said, um, the NQ and DQ methods both take constant time. So those are what are called big O of 1. If you see big O of 1, that means constant time. Okay.
So
Go
my
ahead.
question is this big O? Which one is it, like this?
Like
Like
what?
so, big O of one. What is that? Like, so big O and then one in the parentheses.
Correct.
Okay.
Yeah. So that's what's called constant time. You want to get as close to constant time as possible. Okay.
Got you.
You'll never be able to get, in some algorithms, the best case you can do is like O(n) squared. Like that's like the best you can do mathematically. So you won't always be able to get constant time. But when you're creating algorithms, keep in mind, what the most efficient is. If I can get the constant time, is there a way to do it? And if not, then what's the next best thing? So, well, now that we've had that detour, let's go back to NQ and DQ. So, those are constant time. And there's other operations that the Q data structure has, but we're not going to go over those in this section. You can do your own research for those, and those are like what are called priority queues, circular queues. There's dozens of them, so we really just don't have time to do them all. So we're just going to go over regular queues. So, like I said, a queue typically has an array internally as that holds the data, and it has the NQ operation that adds to the array, and then you have the DQ operation that takes out the first element of the array. Follow me?
Yeah, and then return it, right?
And then it returns that element, correct. So we're going to create a Python version using lists. And we're going to create the NQ method, the DQ method, and we're going to create this method called rotate. And what rotate is going to do is it's going to take the first element out of the array and add it to the back of the array. It'll take the first X element. So if you do rotate 3, it'll take the first 3 elements and add them to the back. And they'll keep their same order. So imagine there was 3 people on line, kind of like when you go to a McDonald's drive-through and they don't have your order ready, so they tell you to pull off to the side.
Yeah.
Right. That same type of thing. All right. So what we're going to do is we're going to create a new class, a new file with a new class. We're going to call this file Q. Q.py. You're and it's QUEU.
That's how you spell the Q.
You need to add UE. It's UEUE.
Okay.
There you go. All right, cool. So exit out of that. All right, so let's create a new class. And we're going to call this class Q. with a capital Q.
Call it again.
Q with a capital Q. I know that sounds confusing, but all right. So in this init function, it's just going to initialize an empty array. Okay. And you can just call it this dot array.
You said we calling it what again?
We're going to call it array. Oh, my bad. Yeah. No. In the init function, so inside of the function declaration, so create. So no, you did it. You did that right. You did that right. We're going to call it init. But you do have to put the def. You're missing the def at the front. Not right there. Right. All right. And then put your parentheses. And then it's going to take self. You put the parentheses. Yeah, in the wrong spot.
We're putting self in the parentheses.
You put the parentheses. You put self in the parentheses, and you put the parentheses. You put the parentheses in the wrong spot. You need to put that at the end of init.
Gotcha. I was looking naked. I was like, okay.
All right, and then put a space.
Colon. Or we're about to write.
Yeah, colon. All right.
Hold on.
No, you're right.
Okay.
All right. Now, new line. All right, and you're gonna do this dot array, and you're gonna make an empty array, or not this. I'm sorry, self. I'm switching up languages. Self dot array, and you're gonna set that equal to an empty array.
To envy.
Empty. Wrong type. Yep. All right. Cool. So you have your empty array, and now we want to make a new function definition called enqueue. ENQUE. So we're done with this we're done with the init function. Now we're going to make a new function or method, and we're going to call. You fix your indentation right there. All right. So we're going to make a new one, and we're going to call this enqueue. ENQUEUE. And then the word queue. And this is going to take as parameters. It's going to take self, and it's going to take item. And then inside of the function definition,
Repeat that again.
Inside of the function definition, So you have to put your colons and then go to a new line. All right. We're going to simply just append the item. So just using, remember, self.array is an array, and we can use the standard array functions. You remember how to add something to an array? We use the append. We use the append method. So we want to add item to the self.array.
I know it's a pin dot.
It's not append dot. It's dot append.
Dot append
On the array.
Self dot append self dot append and item dot append.
No. Self.array.append, because it's an append. The append func method is an array function. So what is your array? So grab your array. Yeah. No. Yeah, my bad. I thought you were about to write a pen. You're right. No spaces. You're gonna call it. Yes.
Okay.
And the append method, it's a method, so it takes an item as its parameter. Awesome. And that's it. You're done.
No calling?
No, you don't need a calling.
Okay.
So now we're going to create the DQ method. So that's DEQ. And that doesn't take in any parameter. It's an empty parameter list. And then inside of the function definition, so do you remember the array method for removing an item from your list?
I don't. I gotta get my memory.
It was the pop method. Now pop. Okay. Well, it's just, I'm telling you, it's pop. P-O-P. So
okay.
The pop method takes in an optional parameter that has an index, and you can pass in the index of the list. So what index is the start of your array? We talked about this earlier in the lesson. Arrays start at what?
0.
Correct. So if you want to call the pop method on your array and you want to get rid of the first element, what would you pass in to the pop parameter?
0.
Correct.
So on this one, instead of a pen, I put pop.
Correct.
Okay.
Now, remember, DQ returns that element. So correct. You did that right, but you're just missing one keyword at the beginning of at the very beginning. If you want to return, yeah, correct. Boom. Awesome.
Okay. So yeah, it's a function, so you can still add return to it. Gotcha.
All right. So now you have made NQ and DQ successfully. And now the last function that I want you to create is the rotate function. Okay. Now rotate will take in X, where X is index.
Is it like a special character, like a capital R, or just regular rotate?
So remember when you make functions, you don't ever use a capital. You only use capital for classes.
Okay. You said we about to take in X.
Yeah, I mean call it index. That would make it easier for you. You can name your variable whatever you want, but yeah. So it takes in X. All right. So what it does is it takes the first X number of elements in the array, okay? And it puts them in at the back of the array. So basically, I want you, before you type it out, I want you to talk it out, okay? So I want you to use the methods that you have already created in your Q class, okay? And you're going to using what you already created. You don't really need to write anything extra. So if you do rotate 3 and in the queue has 5 elements in it, 1, 2, 3, 4, 5, right?
Mm-hmm.
If you did rotate 3, the new array would say 4, 5, 1, 2, 3, because you took the first 3, 1, 2, 3, and you add them to the end of the array, but they kept their same order.
Got you.
Okay.
Yeah.
So before you type anything, talk it out. What are you thinking? Knowing that you don't have to type any new functions, you can use NQ and DQ. What are you thinking?
That we probably gonna take the item and put it in the back. Oh, it's already in the back because we did 0.
Say it again.
But my thing is, what can we take? It's just item.
So you made a function definition. So if you can call in. Let's assume that you made a new queue and you added 5. You call it NQ 5 times, but it doesn't matter. Remember, it's an array. If you want to go over all of the elements in the array, what would you use? What have we been using when we want to go over something? Because you don't know how many elements are going to be in your array. You don't know how many times your user might call NQ. They might call it 1,000 times. And DQ, remember, array 0, like index 0, just means the front of the array. So when you say pop 0, that just means you're just getting rid of the first element. But you don't know how many elements are in your array. You get what I'm saying?
Yeah.
So if you want to loop, if you wanted to go over all the elements in the array, what would you use? What kind of control structure would you use? We've been using them in your other.
Init delete.
No. Okay. If I have 5 things in a list and I want to go over all 5 things and do something, what would I call? We have a while, we have a for.
Oh, got you. What we go over? Like a loop.
Right. So we're gonna loop over all the elements in the array up to X amount of times, right?
So we about to do a while loop.
I mean, I would personally do a for loop. You can do a while loop, but a for loop would be more efficient. So if I call rotate 3 before you type any, don't type anything yet. If I wanted to call rotate 3, that means I would go over the first 3 elements. If I call rotate 5, that means I will go over the first 5 elements.
Got you.
Right?
Yeah.
So without typing it out, speak it out. What would the for loop look like?
So it'd be for while.
For a while, no.
So hold on. If we doing the for loop, what is it? What's the formula again?
The for loop, you have your starting position and then your ending position.
No, I'm talking about the while loop, right?
Right. A while loop just takes an if statement, basically. So you loop while this condition is true. A for loop is for if you wanted to do it 10 times, you do for I equals 0, I less than 10, I plus plus. So that basically saying I want to start at 0, I want to go all the way up to 10, and at the end of each iteration, I could do that. But we're using lists, so we can just say for X in self.array.
I'm still trying to make ends meet on this.
Okay, we're not X.
So we got while loop.
Wait a minute. I want you to change X to index. All right, that is going to make it much easier. So I want you to type in for X in self.array.
For X.
Correct. In.
You said in.
Yeah, in. Self.array. All right.
So for X.
So now, that's saying for every element in the array. Okay. But I'm sorry. We don't want to do this. We don't want to do it this way because we're not going through every element in the array. We're only going through the first. We're going through the first X elements in the array. I'm sorry. I change index back to X and get rid of that and get rid of X in self.array. I'm confusing myself. And also don't forget you got the people on YouTube too who are helping you. You had Andre Wilkinson throw you an answer. Shout out to Andre.
I can't even see any messages, man.
Oh, you know what?
I'm full screen blasted.
Yeah, it's all good. It's all good. All right.
Sorry, Andre, man. I'm just oriented and trying to figure it out.
All right. So we basically want to start at 0 and go up to whatever X is. So like I said, we could call X could be 3, it could be 5, it could be 1. But we want to use a for loop and we're going to start at 0 and we're going to go all the way up to X. So we can call the range function. All right. So we're going to do is for x in range.
Repeat that again.
All right. So we're going to call the range like a ranger range.
After n.
Yeah. And when you got and change the first x, whoa, change x to y. Just that one. Yeah. All right. So for y in range x. All right. No, and I'm sorry, range is a function that takes x as a parameter. No, you didn't have to delete the
Oh,
word.
okay, my bad. I thought we was on another line.
It's a function. Range is a function that takes x as a parameter.
Got you.
There you go. All right. No, wait. X is the parameter inside of the parentheses.
Nah, I got you, man. This mouse I got a new little mouse
It's all,
pad. It's not. It keep on hitting different things. It's
it's
like
all
an
good.
all in one.
It's all good. All right. Cool. So I got one of them too. So so basically what that's saying, we're gonna start off and we're gonna go 0 to whatever x is. Okay. So if x is 3, it's basically saying, go from 0 to 3. If it's 5, range will say range x will be from 0 to 5.
So whatever the amount is, we're gonna plug it in with the range.
Yeah, whatever you pass in to rotate x, that's how big your range is gonna be.
So in this line, we'll be typing like range parentheses, and then
No, we don't need to do anything. Like we just made the for loop, so it's gonna execute however many times we put x into on the rotate function. So if we called rotate 5, it's gonna call this for loop 5 times. If we call rotate 3, it's gonna call this for loop 3 times. Because remember, what is the rotate function supposed to do?
it's supposed to rotate the numbers that you're
What is
taking out and put them in the
what
back,
does it mean?
or whatever.
Say it again. I'm sorry. Say it again.
It's supposed to take the numbers or whatever you're using in your list. Take whatever ones that you're picking out and place them in the back.
Okay, but what does x symbolize?
0.
No. All right.
Hold on.
The rotate function takes x as a parameter, where x is the number of elements that you want to take from the front and put them in the back. So, for example, let's say you have 5 elements in your list, A, B, C, D, E. Okay. If I called rotate 3, the new array is D, E, A, B, C. Because I took the first 3, A, B, C, and put them in the back. So I got 3 people, told them to go in the back of the line.
So whatever elements you place in those parentheses is basically going to go to the back.
The number, we don't know yeah, exactly. But x isn't the actual element, is how many elements, the first x elements.
Correct.
Right. So that's why we put for y in range x. So if x is 5, it's going to run it 5 times. If it's 3, it's going to run it 3 times, because that's how many elements we want to take out.
Got you.
In the back. All right, cool. So at this part, we can finish. We only have 2 lines left, because once again, like I said, we can use the NQ and the DQ methods to finish out our algorithm. So what does DQ do?
DQ basically takes what's in the front and places it in the back.
That's what, huh?
DQ, right?
Yeah, DQ.
The definition or just this function right here?
What does your DQ function do?
So basically, it deletes or takes the number and returns it back into the line.
DQ doesn't take any parameters. Look at your function. Look at line 6 and look at line 7. What is DQ?
So we basically put 0 though when it says pop, right?
But what does 0 represent?
Nothing. Well, yeah.
No. What is pop? Pop is an array function that takes in an index.
Correct.
And what is index 0 on an array, on any array?
The first number.
The first element. We don't know if it's a number or whatever.
Correct.
And pop takes an element out of the array, right? And returns that element. Okay?
Correct.
So
on DQ,
right.
So I'm not understanding what you're asking me on DQ.
So what does DQ do? What does it return?
In this function, right?
What is DQ returning?
So I don't have anything in the parentheses, so
yeah, that I didn't ask what its inputs are. I'm asking what does it output? What does it return? And I didn't ask what it takes in. I'm asking what it returns.
Oh, nothing, because we don't know what's after that 0, right?
It returns something. You have the keyword.
It returns the array. It gives you the same thing that you took out.
We just talked about this. What does pop do?
It basically takes whatever the element is and returning back to the back of the line.
It returns it doesn't return anything you keep saying to the back of the line.
It places it back since there's no line.
No, it doesn't place anything back. That's what rotate is going to do. The DQ method it takes out that element and returns that element. It doesn't put it anywhere, it just returns it. So if you say pop 0, it's going to take the first element out of the array and it returns it back to you. So if I return self.array.pop0, I'm basically returning the first element of the array it was in the array. It's no longer in the array. We popped it out, but it's returning that element that was in the array. Okay. It's no longer in the array anymore because we popped it out. It's just returning what used to be in the array. You feel me?
Yeah, I'm just.
What do you?
I gotta see probably a different function to kind of just make sure that I'm confident of what I'm thinking.
What are you confused on? So I can.
So basically, you saying, okay, it pops it out, right?
Right. And
it doesn't return. Because what I mean by getting back in line is basically like, it's returning back to.
Okay. All right. Then yes. So if we had
it's getting back to 3, so it got deleted, but they populated it back.
It didn't pop when you're saying populate. I'm hearing put it back in the array.
Well, we don't got a list. Okay, I got you. We gotta speak strictly what you speak, and I can't think in a different way. I gotta stay focused on what you thinking.
If we have goat, monkey, sheep and I do pop 0, it returns goat because goat was in the beginning. It was in position 0, but it's no longer in the array. But it's still returning what it was when it was in the array, which was goat. But now the array just has monkey sheep. It doesn't have goat in there anymore.
Correct.
Right. Okay. Cool.
So I get where I'm lacking at. When you mean return, you said it's not in the function no more, right?
It's not in the array.
In the array.
Correct.
So where did it return it to?
It returns it to the function that's calling the pop function, which in this case is the Q function. When you call the Q, when you call a function and it returns something, it basically it's returning to the function, to the process that called that function. And in this case, it's the Q function. Inside, you're calling pop, so it's returning to the Q.
Okay, so basically, if it's in Q, and then pop call it, it's gonna go where it's returning to the DQ.
Correct.
Okay.
And now in the DQ function, we want to return a value. So we're literally just returning what pop returned. We're just like return.
Okay, because in my head, I'm thinking return like you just giving it right back to where you got it from.
Got you. Okay. All right. Got you.
So you see, that's where my terminology is at. That's why I have
to return is synonymous with output. You have your input, your output. Input, output. Return is your output.
Okay.
All right. So cool. So we know.
Damn, that shit had me in my mind twisted like a mug. I can't believe I let my stuff go that basic. I was in the grocery store, man, talking about return. That's what I was thinking about.
It's all good. All right. So we know. So let's go back to the rotate function. So we know that we want to take out the first X elements, and then we want to add those same elements back too. So the NQ. So if you know DQ is going to return an item, right? And NQ takes in an item, right? And you're looping through your range. What do you think you need to do? Take me through your thought process. We're already inside of the for loop, and we know, what do we want to do? And keep in mind that the optimal algorithm can be done in 2 lines. Because you've already wrote the hard part.
Yeah. Hold on. So I think I got a question. Because I just wrapped my head around the return part. So now I'm really understanding the top. And so the rotate basically takes them out and play whatever elements you want. Choose whatever element numbers and place them back. So we call it return. Then we rotate. Okay. Now, what was your question again? Because I'm just trying to wrap my head around it again. Since we got that cleared up with the return part.
All right. So we know that DQ is going to return an item, right? It's going to return the first item that was in the queue, right?
Right.
Right. So we know that is going to return something, and we know that the enqueue method takes in an item and adds it to the back of the queue, correct?
Correct.
So if we have
live streaming is on.
So if we know that we have one function that returns an item from the front, and we have one item that adds an item to the back, and we have a function that takes the first X items from the front and it adds them to the back. And we've already got the for loop. What do we need to do?
Give it its range.
We already did the range part. We're done with that. We're inside of the for loop now. So now remember, the for loop represents each rotation is we're down to a single we're down to a single iteration. So now we're the first thing you want to do is you want to get your item. So how are we going to get the item from the front? And we want to save it to a variable, which I would suggest that you call it item.
I'm still lost.
Okay. Let's start off here. Create a variable, call it item. And you need to fix your indents because you're inside the for loop. You're inside the for loop. You're inside the for loop. Go back right there. All right, so let's create a variable. We're going to call it item. All right. How are we going to get the item from the front? Because that's what we're doing, right?
So we're going to do item equals what?
That's what I'm asking you. If you know that we already have, I'm sorry. Rotate takes in self and X.
Okay.
And DQ takes in self as well.
So what the fuck is happening?
This SELF, comma.
I thought I pressed it.
And DQ line 6. All right, cool. So you know you have a function that can return an item, right? So if you want to initialize your item variable using a function that you've already built, what do you think you should call? And it's a self function.
So you saying we want to add it, right?
Eventually, yeah, but we got to take it from the front first. We got to take it from the front, add it to the back.
DQ.
Correct. So item equals self.dq. And that's a function. Right. Perfect. Now what are we going to do on the next line?
So what is our main objective with the item again?
You take it from the front.
And we put it in the back.
And then we put it in the back. So how we add it to the back? Fix your indentation. Oh yeah, you got a typo there. All right, cool. So yeah, so how do we add now that we have that item? How do we add it to the back?
Got you. Append.
Why would you? Okay, using what's the opposite of DQ?
NQ.
Okay. And what does NQ take as a parameter?
Self an item or item.
Okay. And you got item. You have item.
Correct.
And NQ is the opposite of DQ.
So
And
we
NQ takes in an item.
and we'll add it back. Oh, we'll add it back. Okay.
So how are you going to call NQ?
Basically by pop.
No. How do you call the? How are you going to call the NQ function? How did you call the DQ function? What did you type in to call
Return
what on line 10? What did you type in to call the DQ function?
item.
On line 10, what did you type in to call the DQ function? What is that word? What literally? Read it out. Read it out loud. Item equals what?
Item equals self dot DQ.
So how are you going to call NQ?
Oh, okay.
No, you don't need what NQ. You don't need to do anything with item. You just need to call NQ. I just need you to call the NQ function.
So what's gonna be the
How did you call the DQ function? What did you type in? You just said it.
item equals self dot DQ. But I'm saying
Get rid of the item equals. Get rid of item equals. How do you call? Because item equals isn't calling the DQ method. There you go. Correct. Well, we're not calling DQ anymore. Mm-hmm. And that takes in what as a parameter?
item.
Correct. And then you're done. You don't need a.
Gotcha.
So that's basically saying for 0 to whatever x is, I want you to take. So I want you to take that first item, take it off, and add it to the back.
Gotcha. It's just that sub dot NQ, that should look plain, if it don't got no symbols, no equal sign.
Exactly. No. Because we're not, and that's because we're not returning anything in NQ. So
yeah, I was thinking too hard for a formula. I was looking for like no equal sign, like
yeah, we don't need it because we want this to be as efficient as possible. And NQ, we're not returning anything. So why would we set anything equal to NQ? Because you only set something equal to a function that's going to return something. Because if it's not going to return anything, then how are you going to set it equal to anything?
Got you.
So that's what, when you call it item equals self.NQ, DQ, well, that's because DQ actually returns something.
Got you. Definitely.
All right, cool. So what I want you to do is go start a new line. And we're going to make a new queue. So make an item, make a new variable. Let's call it. Do a couple spaces. All right. So let's make a variable. Let's call it q, lowercase q.
Call it pew.
Yeah, you messed up your line. I don't know what happened there. Yeah, call it q, lowercase q, q.
Oh.
All right, and we're gonna set that equal to a new q, to a new q class. Mm-hmm. That will okay. If we're doing a class, if we're doing there you go. Yep. Just hit enter. There you go.
Hold on, man. This fucking mouse fucking me up. I'm done with this shit. Excuse my language, guys. Oh, no, that's better.
All right, that doesn't. That's not going to take in a colon. You're instantiating a new class, so that makes it an object, which means you need to do parentheses because it's going to call the init function. Remember? There you go.
You said we're about to use the init function?
No. That's the init function is called every time you do a new instantiation.
Okay.
All right.
So Q equals new Q.
Right. Exactly.
Okay, yeah, Q is the main structure. So we basically about to give this really just the functionalities.
Yeah, I'm sorry. You can get rid of the new keyword. I'm switching languages. Just get rid of the new keyword. But you did the Q part right. I know so many languages, and other languages got to do new. Yeah. All right. So Q equals Q. Now I want you to add I don't know. Let's do we just do numbers. All right. So do on the new line. Let's do Q dot in. Why did you do okay. Yeah. Q dot NQ1, Q dot NQ2, Q dot NQ3. Not NQ, you gotta do dot NQ EN. All right. Cool. So yeah, NQ, and then that's a function, so or a method. So it takes in parentheses and then put the number 1, right? And then do the same thing again and put the number 2, then do the same thing again, do the number 3. All right, and now I want you to print Q dot array. Why do you you don't do indentation unless you have semicolon or colon.
Okay.
All right, so print and Q dot array. All right. Now I want you to call the rotate function on a new line. There, yep. Call the no. I want you to call the rotate function on your queue. So queue.rotate. And I want you to call it 2. Put parameter 2. So I want you to rotate the first 2 elements. Now I want you to do print queue.array. So the first time you print queue.array, what do you think it should show you?
First time you print, it's gonna print 1, 2, 3.
And then the second time, what should it print?
1, 3.
Huh?
1, 3, 2.
No.
Oh no, sorry, don't say the answer yet. So when you rotate 2, it's gonna take the first 2, which is 1, 2, and put them in the back of 3. So it's gonna be 3, 2, 1.
No. I mean, you said the definition right, but then you said the answer wrong.
Hold
It
on,
keeps the same order.
So it's gonna be what? Oh, 3, 1, 2.
Correct.
Okay. Yeah. Okay.
All right.
I get that. I get the definition of it for sure now.
Cool. All right. So save that and run it. And let's make sure it does it. You're gonna call Python.
Yeah. I forgot how to call it. Hold on, no, I got it. No, I forgot. Hold on. How do I call my desktop again? Is it just desktop?
You spelled desktop wrong.
Man, I gotta get some. I gotta get something to eat. So CD.
And it's capital D, I think. Just hit the up arrow. What are you on? What is that? Windows?
Yeah.
CD space backslash lowercase d. No, just backslash lowercase d. You get not desktop, just lowercase d. What the hell?
Hold on.
I don't. This is part of the reason I'm not Windows. All right. See. Did you do front slash or backslash? Well, you're not supposed to put the backslash in front of the CD. I know that much. All right, CD space capital C colon backslash users backslash. Oh wait, are you already? You already just CD space backslash desktop capital D.
Backslash.
Yeah. DESK.
And that's a forward slash.
You had it right. Yeah, desktop. What the hell? Did you must have return? Hit just type in CD. No. Type in exit. Exit with the parent. Okay. Wait a minute. Type in PWD. PWD or DIR. All right, no backspace. Just type in CD desktop, capital D.
Okay.
All right. All right. Acute object. So. What? Change. Oh, that's annoying. What the hell? This is Q line 15.
Line 5.
Oh, my bad. Let's define a print function in the Q class. Let's make a new function called print. And all it does is print self.array.
Line 12.
Correct. So it needs to have the same indentation as the rest of the method. No, there you go. So define, and we're gonna call it print. And it's just gonna take in self, and then inside of the definition, all you're gonna do is print self.array inside of the definition. Yeah. No. Inside of the definition of the method, the definition is everything inside of the semicolon.
So we put a semicolon at the end, right?
Correct. And And then when I say the definition, that's everything underneath the semicolon.
Gotcha.
You're going to print self.array.
So
Now on line,
go ahead.
On line 19 and line 21, replace those lines with q.print. Replace that whole line with q.print.
So don't hit print.
Replace the whole line with q.print. And remember, it's a function. All right, now save and rerun the program. What? Self.array. All right, let's change self.array. Go to the function. Go to the program code. Hit Control-Shift-F. And type in array. And on the next line, on the next line, type in data, underscore data. All right. And then hit find all to the right. And replace all. Yes. And go back to your file. All right.
Oh, that's dope. That boy saved hella time. He said,
all right, and go back and try to run it.
oh, here, hold on. Let me save it.
Okay, what is going on? Did we mess up the init function or something? Let's see. Object has no attribute data. Init. You have 2 underscores on your init function.
I probably got more.
All right, make sure it's just 2. Yeah, okay. All right, that's why it didn't work. All right, cool. Save it, run it, should work.
Yup. Okay.
All right, cool. So the last thing before we get off here is we're going to do the runtime analysis of the rotate method.
Gonna do what?
The runtime analysis, the big O notation of the rotate method. So we know that DQ is a big O of 1, and we know that NQ is big O of 1, right?
Mm-hmm.
However, the function depends on N because we're doing the for loop depending on how big X is. So worst case scenario, the person puts in a number that's the size of the whole list, right? In which case we have to go through the whole list. So therefore, the runtime analysis of the rotate function is big O of n, because where n is how much, how many numbers are put in. Because how long it takes for that for loop to complete depends on how big of a number x is. That makes sense?
A little bit. It's connecting with me a little bit.
Okay. Well, what I want you to do is I want you to read up on queues tonight. Tomorrow we're gonna do stacks, which are the opposite of queues, and we're gonna do some similar stuff. So I want you to just basically make sure you understand what's going on here. Read up on queues,
Gotcha.
and we're gonna get started with stacks.
Okay, definitely, I could do that.
All right, man. Cool. I'll talk to you later.
Thank you for your time, man. Have a good one. Enjoy your night.
You too. Bye.
All right.